So this is lesson or Unit 2, Lesson 2 for our Precalculus 12 class. Unit 2 is called Parent Functions. Parent as in your mom or your dad. Lesson 2 is called Graphing Absolute Value Functions. What we will learn in this video is what does the graph of an absolute value function look like, and how to write an absolute value function as a piecewise function, or what even a piecewise function is. So if you recall from the last video, absolute value means distance from a certain point, 0. So if Mr. T-Rex is point 0, you don't care where you are, you care about your distance from point 0. An absolute value is the same thing, how far away. So if we look at just a basic parent function, f of x is defined as the absolute value of x. We're saying whatever our input is, the output is the absolute value. So if we just pick some x values here, and I space them out a little bit so we get some points across the graph, we could see that any input is going to be how far away from 0. Well, that just means they're all going to be positive distances from 0. So -6 is 6 away from 0, just like 6 is also 6 away from 0. You can see that on the number line, yeah. So if we graph these points, on the left side of our graph, quadrant 2, we get this blue line. On the right side, we have this green line. And combined, they make the graph for our function f. What we notice is a couple things. One, the green line, the green half, is part of the line that is graphed as the linear equation y equals x. And we mean if you think about our basic linear equation, y equals mx plus b, this is that. With an m of 1, as in we have a slope of up 1, right 1, and a y-intercept of 0, or plus 0. The blue line is similar, but it's the negation of the slope. So we have a slope of positive 1 on the green side. On the blue side, we have a slope of negative 1, as in this blue line goes down 1, right 1 every time. Also has a y-intercept of 0. One other thing we notice is that we have domain of all real numbers. You can input any value of x into the absolute value, and you can get a reasonable answer that's a real number as well. We notice that our range is any value greater than or equal to 0. So our range again is our output. We can get any input we put in for x. The only outputs we can get are 0 and any positive number. You can't put a number in for x and take the absolute value of it and have a negative number come out, because absolute value means distance. You can't have a negative distance. So for our range, our y value is greater than or equal to 0. So here's an example. F of x is equal to the absolute value of x plus 4. So if we pick a few points and just kind of play around with this and see what the graph looks like, we can get a sense for how to write the piecewise function. So if I pick these points, -7, -5, -4, -3, and -1, we get the following V graph. And we can see that the V graph is a combination of two linear equations that are cut at the x value of -4. To the right of -4, we have the green line with a positive slope of 1 and a y-intercept of 4. The blue line, if we continue the blue line beyond -4 to the right, we would see that it would intersect, and we continue our slope of down 1, right 1, down 1, right 1, all the way to the y-axis. We see that we have a y-intercept of -4, and we know our slope is also -1. And an important distinction here, -x minus 4, if we factor out a common factor of -1, we see that we have negative x plus 4, which is useful because x plus 4 is the equation of our right side of the equation. And so what this tells us is if we take the right side and just multiply it by -1, we get the left side's equation. Or if we had a negative slope inside here, it would be vice versa. So that's that. Notice our domain is still all real numbers. We can put any value in for x we want. Notice our range is still greater than or equal to 0 for this graph. So now if I wanted to write the same function as a piecewise function, what we're doing is we're taking two linear equations, or two linear functions, and we're cutting them at the value of x equals -4. And so I'm going to say when we're to the right of -4, it's this green line. So f of x is equal to x plus 4 when we're to the right of -4. That's what this says right here. And then it's going to equal -x minus 4 when we're to the left of x equals -4. So f of x equals -x minus 4 when we're to the left of -4. That's what this says right here. You may notice that I put a greater than or equals to sign on the top equation. And that's to show that when I plug in -4 itself, I can put it into the top equation and get 0. And that's our vertex right here. What would also be correct, you could also write, instead of putting the greater than or equals to here, you can make this strictly greater than, and you could put that line down here and make this less than or equals to. Because if I plug in -4, and for this equation, I get -4, which is +4, minus 4, which is also 0. So each of these equations at x equals -4 gives us the same answer of -4 comma 0 on our graph. So we really could put that equality symbol on either inequality, and this would be correct. Now the next thing I want to say is if you were to be asked this question without having done the graph ahead of time, if this was the question right here, write this as a piecewise function, how would you do that? Well, we need to know where the vertex is, the point between the two lines, and then we could just find the positive slope side and the negative slope side accordingly. So if I want to find the vertex, I'm going to take our input for our function, as in the thing inside the absolute value, in this case x plus 4, and I'm going to set that equal to 0. And what that's going to do, if I solve for x, that'll give me the x value of the vertex. And so we can think about this as the parent function, the vertex is at 0. So for adding 4, then we're translating our x value a little bit, and we'll get more into that in the next lesson. So anyways, we can use this little trick right here to find the x value of our vertex, which cuts through the center of our v. And then if we consider, okay, x plus 4, well, that's on the right, so we'll say x plus 4 when we're to the right of -4, and the negative slope is on the left side of the v, so we'll use that when we're to the left of our vertex, -4. So here's our piecewise function. Let's look at one more example of that without looking at the graph first. So I have 10 minus 2x. Well, if I want to find the vertex, I'm going to consider when does 10 minus 2x equal to 0. And when I solve that, I find that x is going to be 5. And so that tells us that the point 50 is the vertex of our v. If I look at our graph as it is, I notice that this is kind of slope-intercept form of a linear equation with a -2 slope and a y-intercept of 10. And so if I visualize this on my graph, a negative slope is going to occur on the left side of the v. And the v is cut at x equals 5. So this is going to be our linear equation when we're to the left of x equals 5. So when x is less than 5 is going to be our base equation. Now, if we want to find the right side, we want to find when we have a positive slope. So the positive slope is when we multiply this input expression by -1. So 10 times -1 is -10. Negative 2x times -1 is positive 2x. So this equation is a linear equation with a positive slope of 2 and a negative y-intercept of 10, -10, excuse me. And so we know the positive slope should be on the right. So this is our expression of our linear equation when x is greater than 5, or to the right. Now again, we put the inequality on the top. We could have just easily put that equality piece on the bottom and it would still be correct. So here's the actual graph of that one. We can see the graph of V. We see the vertex is at 5, 0. Ooh. There's our vertex, and then to the left of that thing we have our negative slope line, and to the right we have our positive slope line. So takeaways, we now know that the graph of an absolute value function looks like a V, and this is a lesson we did in February, just in time for Valentine's Day. So if you wanted to give a Valentine's Day card to a nerd, instead of writing happy V day or whatever, you could put happy f of x equals the absolute value of x day. And maybe they'll understand that. Or maybe that's just a terrible idea and you shouldn't even do it. Anyways, we also learned how to write an absolute value function as a piecewise function. And that's it for this one.